A very good morning to all of you. Myself Deepti Jain, a lecturer in GPC Mohali, Khuni Majra. I am here to present a lecture on protection of transformer. So let us first discuss what is the power system protection. So power system protection is a branch of electrical power engineering that deals with the protection of electrical power systems from faults through the isolation of faulted part from the rest of the electrical network. So power system protection is necessary for the power system to isolate the faulted part from the healthy part. And the main objective of the protection scheme is to keep the power system stable by isolating only the components that are under fault while leaving as much of the network as possible still in operation. So only the faulty part is isolated by the power system protection components while the healthy part will keep in operation. Thus, the protection schemes must apply a very pragmatic and pessimistic approach to clearing system faults. So, for this reason, the technology and philosophies utilized in the protection schemes can often be old and well established because they must be very reliable. So, we can say that power system protection is that branch of a power engineering which is used to isolate the faulted part of the power system, and it will keep the power system stable, which part is the next is the various components of power system. The protection systems usually comprise of mainly 5 components. The first main protection components are CTs and PTs, that are current transformers and voltage transformers. So, current and voltage transformers are used to step down the high voltages and currents to the electrical power system to convenient levels for the relays to deal with. So, the main function of CTs and PTs, they just record the values of the current and voltage, and if they are above the normal value, then they will provide signal to the relays. Now, second main component of the power system is protective relay. Now, the relays are basically used to sense the fault, and they will give the signal to the circuit breaker which is nearby the fault. So, we can say that protective relays are used to sense the fault and initiate a trip or disconnection of the faulty circuit. So, the relays will sense the fault and give the signal to the circuit breaker. The next is the circuit breaker. Now, circuit breaker is a kind of switch which can operate even in normal condition and in the abnormal condition. So, during the abnormal condition, the circuit break will operate automatically, and it will operate when it will receive the command of the relay. So, next is the batteries. Now, batteries are used to provide power in case of power disconnection in the system. So, mainly the relays require the DC supply. So, that is why the batteries are required, and it is considered as a main component of the power system, because if batteries are not available, then the relay will not operate, and so the fault will remain continuous. So, this will lead to a major major loss in the power system. Next is protection system. So, we can say that a series of devices like relays, circuit breakers, CTs, PTs, and you can say the batteries, whose main purpose is to protect persons and primary electric power equipment from the effects of fault. Now, next is there are many costly components in the power system like generators, transformers, feeders, bus bars. So, their protection is very important as they are very costly. So, let us discuss the protection of transformer today. So transformer, as you know, is a static device and there is no any moving part. So the friction losses are almost absent in these cases. So the chance of occurring a fault is very rare. But transformer is a static device generally immersed in oil and is placed in a sealed tank. Therefore, the chances are very rare chances of internal faults. But if it occurs due to any reason, it may damage this costly device. Therefore, this necessitates to provide adequate automatic protection for transformers against internal fault. So, that's why in case of internal faults, the protection of transformer is very important and we cannot ignore them. Now, for the small pole mounting distribution transformer, they are connected to the supply system usually for the 11 kV lines through series or rewirable fuses instead of the circuit breakers. Therefore, no any automatic protective relay equipment is required. However, the probability of faults on the power transformer is more and hence automatic protection is absolutely necessary. So, we can say that the automatic protection is necessary, mainly necessary for the power transformers as compared to the distribution transformer. The next is the common transformer faults. Now, there are main three types of faults that mainly occur in the power transformer. The first is the open circuit faults, second is the faults due to the overheating, and third is the winding short circuit faults, that is the faults due to earth. The second is phase to phase faults and the interturn faults. So, let us discuss all the three faults one by one. The first is open circuit. Now, an open circuit in one phase of a three-phase transformer may cause undesirable heating. So, open circuit, you can say that when one of the phase from the three phases of a transformer gets open. So, this in this situation undesirable heating can occur, but in practice no automatic relay protection is provided against open circuit faults because this condition is relatively harmless, and on the occurrence of such a fault usually transformer is disconnected manually. So, we can say that for this type of fault we doesn't require any automatic protection, we just disconnect the transformer manually. The second fault is due to the overheating of the transformer. Now, this overheating of the transformer is usually caused by sustained overloads or short circuit and very occasionally by the failures of the cooling off system. So, see, there are three reasons by which the overheating of the transformer can occur. The first is the overheating can be due to the overloading of the transformer. Second, it may be due to the short circuiting, and the third main reason is the failure of the cooling system of the transformer. So, in these three cases the overheating of the transformer may occur and this may harm the transformer. But in this case also no automatic relay protection is provided. So, as the previous case like the open circuit, here no any automatic relay protection is required. However, the thermal accessories are generally used to sound an alarm or control the banks of the fans. So, for the first two faults we doesn't require any automatic relay protection, and we can disconnect the transformer manually as it desired. The third main fault is the fault when the windings gets short circuited. So, windings short circuit, the main examples are earth faults, Second is phase to phase faults, and the interturn faults are the internal faults which may damage the transformer. So, due to these three types of faults, the winding short circuit can occur. So, therefore, under these faults, the transformer must be disconnected from the supply system quickly with the help of relay and circuit breaker. So, see, remember, from the three types of faults, open circuit, overheating and winding short circuited, the third fault is a main fault which requires the automatic protection, and in this type of fault the transformer must be disconnected from the supply quickly. So, let us discuss the protection schemes of the transformer. So, for the winding short circuited protection, we have mainly four types of protection schemes. So, let us discuss. Now, for the protection of alternators, Merz-Price circulating current system is unquestionably the most satisfactory. Therefore, the same system is quite suitable for the protection of transformer, but some other protective systems are also employed for the protection of transformer, now which are given below. So, we can say that in spite of the Merz-Price protection, there are another three schemes for the protection of transformer. Now, first is the Buckles relay protection, second is earth fault, or you can say the leakage protection, second is the combined leakage and overload protection. So, Buckle relay protection is mainly used for the internal type of faults. The second is earth fault or leakage protection. Now, this type of protection is used for the earth faults. Third is combined leakage and overload protection. This type of protection is provided both for the earth leakage and the phase to phase fault. And fourth is Merz-Price protection. Now, this is a very important protection. Now, this is used for the internal as well as phase to phase faults. Now, first is Buckles relay protection. Now, Buckles relay is named after its inventor, that is the Buckles. It is a gas actuated relay installed in the pipe connecting the conservator to the main tank. So, let us discuss the position of the Buckles relay. So, Buckles relay is provided in between the main tank of the transformer and between the conservator. So, you can say that the Buckles relay is in middle between the conservator and the main tank. So, it protects the transformer against all type of internal faults. So, it is used for the internal faults. Mostly these relays are used on all such oil immersed transformers having a rating 750 kVA and above. So, this type of protection, that is a Buckles relay protection, is only applicable for the transformers having a rating above or 750 kVA. So, this star means the use of the Buckles relay with the transformer having capacity below 7 kVA is uneconomical. So, in the last I can say that the Buckles relay is only applicable for the transformers having rating 750 kVA and above, and below 750 kVA this Buckles relay is uneconomical. So, this is the diagram of Buckles relay. So, see, this portion is connected to the conservator and this portion is connected with the transformer, or you can say the main tank of the transformer. So, this is the alarm circuit 1, trip circuit 1, this is another trip circuit and alarm circuit. So, these are the mercury switches which will detect the temperature again, so we can say that in the internal we have two mercury switches and two trip circuit. So this Buckles relay is filled with oil. Now these are the deflector plates. So see, let us discuss the construction of the Buckles relay. So it takes the form of a domed vessel placed in the connecting pipe between the main tank and the conservator. So remember the location of the Buckles relay, it is always connected in between the main tank and the conservator. The device has two elements. The upper element consists of a mercury type switch attached to a float, and the lower element contains also a mercury switch mounted on a hinge type flap located in the direct path of the flow of the oil from the transformer to the conservator. So the upper element closes an alarm circuit during the incipient faults, whereas the lower element is arranged to trip the circuit breaker in case of severe internal faults. So ਹੁਣ ਆਪਾਂ ਕਹਿ ਸਕਦੇ ਹਾਂ ਕਿ ਜਿਹੜਾ upper element ਹੈ ਇਹ ਉਦੋਂ ਕੰਮ ਕਰਦਾ ਹੈ ਜਦ ਫਾਲਟ ਆਉਂਦਾ ਹੈ, ਪਰ ਜਿਹੜਾ ਕਿ ਸਵੀਅਰ ਫਾਲਟ ਨਹੀਂ ਹੁੰਦਾ ਹੈ। ਮਾਮੂਲੀ ਟਾਈਪ ਦੇ ਫਾਲਟ ਵਾਸਤੇ ਜਿਹੜਾ ਅਪਰ ਐਲੀਮੈਂਟ ਹੈ ਇਹ ਸਿਰਫ ਆਪਾਂ ਨੂੰ ਅਲਾਰਮ ਦੇ ਦਿੰਦਾ ਹੈ, ਬਟ ਜੇ ਸਰਕਿਟ ਦੇ ਵਿੱਚ ਟਰਾਂਸਫਾਰਮਰ ਦੇ ਵਿੱਚ ਸਵੀਅਰ ਫਾਲਟ ਆ ਜਾਂਦਾ ਹੈ ਤਾਂ ਜਿਹੜਾ ਲੋਅਰ ਐਲੀਮੈਂਟ ਹੈ ਇਹ ਸਰਕਿਟ ਬ੍ਰੇਕਰ ਨੂੰ ਟ੍ਰਿਪ ਕਰਵਾ ਦਿੰਦਾ ਹੈ। Now Buckles relay operation. The operation of the Buckles relay is as follows. So in case of incipient faults within the transformer, the heat due to fault causes the decomposition of some transformer oil in the main tank. ਕਹਿੰਦੇ ਜਦ ਵੀ ਬਹੁਤ ਮਾਮੂਲੀ ਤਰ੍ਹਾਂ ਦਾ ਫਾਲਟ ਆਉਂਦਾ ਹੈ then transformer ਦੇ ਵਿੱਚ then the heat due to the fault causes the decomposition of some of the transformer oil in the main tank. So due to the faults, the level, the temperature in the Buckles relay, the temperature in the main tank increases, which causes the oil to vaporize. So that oil takes the form of a gas. So the products of decomposition contain more than 70% of hydrogen gas. So the hydrogen gas being light tries to go into the conservator. क्योंकि हुन जिहड़ी गैस है वो हल्की हुंदी है, so it will try to go into the conservator through the Buckles relay, and in the process gets entrapped in the upper part of relay chamber. So जद ये गैस उपरले मरकरी स्विच के नाल टच होकर कंजरवेटर वाल जाती है, then when a predetermined amount of gas gets accumulated, it exerts sufficient pressure on the float to cause it to tilt and closes the contacts of mercury switch attached to it. So इस गैस की वजह दे नाल जिहड़ा वो फ्लोट है वो टिल्ट हो जाता है, जिस दे नाल जिहड़ा मरकरी स्विच के कंटैक्ट्स है वो क्लोज हो जाते हैं. सो दिस कंप्लीट्स द अलार्म सर्किट टू साउंड एन अलार्म. क्योंकि ये अपर कंटैक्ट है, अपर है, ये सिर्फ आपां नूं अलार्म दिंदा है और इस सिचुएशन ते आपां नूं ट्रांसफार्मर नूं डिसकनैक्शन देण दी कोई ज़रूरत नहीं हुंदी. बट इफ अ सीरीयस फॉल्ट अकर्स इन द ट्रांसफार्मर, सो दूसरी सिचुएशन है जब ट्रांसफार्मर दे विच कोई सीरीयस फॉल्ट आ जाता है, an enormous amount of gas is generated in the main tank. क्योंकि हुन level of fault serious है, so more heating will be produced in the tank. So due to that enormous heat, the more of the oil gets evaporated. So it will turn into the gas. So the oil in the main tank rushes towards the conservator via the Buckles relay, and in doing so tilts the flap to close the contacts of the mercury switch. So जिस दे नाल जिहड़ा mercury switch है उहदे फिर contacts close हो जाते हैं, and this completes the trip circuit to open the circuit breaker controlling the transformer. So इस situation दे विच जिहड़ा lower trip circuit है वो सर्किट ब्रेकर नू ट्रिप करवा दिंदा है और इस तरह आपां ट्रांसफार्मर नू डिसकनैक्ट कर दिंदे हैं सप्लाई तो. Next is the advantages. It is the simplest form of transformer protection and it detects the slow developing faults at a stage much earlier than other forms of protection. And the disadvantages are it can only be used with oil immersed transformers equipped with conservators, and the device can detect only faults below oil level the transformer. Therefore, the separate protection is needed for connecting cables. So, this is a simple view of a Buckles relay. So, see, this is the lower Mercury switch which is used during the severe faults, and this is the upper Mercury switch which is closed, which gets closed during the normal faults, which is not very severe. So, this is the first alarm circuit and this is the second alarm circuit. Now, this side of the Buckles relay is connected with the conservator and this side is connected with the main tank of the transformer. Now, second protection scheme is the earth fault or leakage protection. So, let us discuss what is this. An earth fault usually involves a partial breakdown of winding insulation to earth. So, this the resulting leakage current is considerably less than the short circuit current. So, remember it, the value of the leakage current is normally small than the short circuit current. So, mind it, this line is very important. The resulting leakage current, that is the earth fault current, is considerably less than the short circuit current. So, the earth fault may continue for a long time and cause considerable damage before it ultimately develops into a short circuit. So, कहते कि चाहे जिहड़ा अर्थ फॉल्ट है ये शॉर्ट सर्किट करंट तो ज़्यादा सवीयर नहीं हुंदा, पर जे आपां इसनूं ज़्यादा देर तक कंटिन्यू करन दईए then it will take a severe form. So, that's why and आपां नूं जिहड़ी अर्थ फॉल्ट प्रोटेक्शन है ये ज़रूरी हो जाती है ट्रांसफार्मर वास्ते. So, under these circumstances it is profitable to employ earth fault relays in order to ensure the disconnection of earth fault or leak in the early stage. So, an earth fault relay is essentially an overcurrent relay of low setting. जिहड़ी अर्थ फॉल्ट रिले कोई होर नहीं हुंदी, ये आपां ओवरकरंट रिले ही यूज़ करते हैं, पर इहदे वास्ते जिहड़ी आपां करंट सैटिंग कीती हुंदी है ये आपां घट कीती हुंदी है and operates as soon as an earth fault or leak develops. So, one method of protection against earth fault in the transformer is the core balance leakage protection. So, earth fault वास्ते जिहड़ी आपां protection transformer वास्ते यूज़ करते हैं उसका नाम है core balance leakage protection. So, आपां हुण कह सकते हैं कि जिहड़ा earth fault है चाहे इसकी जिहड़ी वैल्यू है शॉर्ट सर्किट करंट तो बहुत ज़्यादा घट हुंदी है, पर जे ये लंबे समय वास्ते चलता रहे तो ये एक सवीयर फॉर्म लै लैंदा है. इसलिए ट्रांसफार्मर की जिहड़ी प्रोटेक्शन है अर्थ फॉल्ट वास्ते बहुत ज़रूरी हो जाती है. सो इसलिए जिहड़ी स्कीम आपां यूज़ करते हैं ट्रांसफार्मर की प्रोटेक्शन दैट इज़ कोर बैलेंस लीकेज प्रोटेक्शन स्कीम. So, this is a core balance leakage protection scheme. So, see, this is a core of the current transformer and this is the secondary winding which is connected to the relay, or you can say to the trip circuit. Now, this is a power transformer. Its primary is connected in delta and secondary in star. So, you can say that this is a delta star transformer. So, the three leads of a primary winding of power transformer are taken through the core of a current transformer which carries a single secondary winding. So, this is a single secondary winding, and the operating coil of the relay is connected to this secondary winding. की है कि so this is a zoomed view of the core balance leakage protection. So, three phases are there, RYB. This is a current transformer, this is a power transformer, and the primary is connected in delta, secondary is connected in star. So, this is a delta star transformer, and with this primary we have connected a CT which will measure the value of the current. So, if there is any earth leakage, or you can say that if there is any earth fault in the transformer, then this CT will measure that value, and that fault current, earth fault current, will energize the relay coil of the trip circuit. So, working is under normal condition, that is no fault to the earth, the vector sum of the three phase current is 0, that is IA plus IB plus IC is equals to 0, and there is no resultant flux in the core of current transformer. No matter how much the load is out of balance. Now, consequently, no current flows through the relay and it remains inoperative. However, on the occurrence of the earth fault, the vector sum of three phase currents is no longer 0. Excuse me. ਹੁਣ ਆਪਾਂ ਕਹਿ ਸਕਦੇ ਹਾਂ ਕਿ ਜਦ ਵੀ ਅਰਥ ਫਾਲਟ ਆਉਂਦਾ ਹੈ ਟਰਾਂਸਫਾਰਮਰ ਦੇ ਵਿੱਚ, ਤਾਂ IA plus IB plus IC A that will not be equals to 0. So, that resultant current sets up flux in the core of the CT which induces EMF in the secondary winding. So, see this diagram, when IA plus IB plus IC is not equal to 0, ਤਾਂ ਜਿਹੜਾ ਉਹ resultant current ਹੈ it will flows through the secondary winding of the CT. So, when this current, resultant current links with the secondary winding, it will produces flux, and therefore, the changing flux produces EMF in the relay coil. So, when the relay coil gets energized, it will give signal to the trip circuit. So, this energizes the relay to trip the circuit breaker and disconnect the faulty transformer from the system. So, in this way we can disconnect the faulty transformer from the healthy system. Now, next is the third main protection scheme, that is a combined leakage and overload protection. Now, see the previous protection scheme, that is a earth leakage protection. This is only used in case of earth faults. So, that scheme will not respond for the phase to phase faults. So, the third scheme is used for the earth faults and the phase to phase faults both. The core balance protection described above suffers from the drawback. So, here I have mentioned the drawback of the previous scheme, that it cannot provide protection against overloads. So, if a fault or leakage occur between phases, the core balance relay will not operate. Therefore, it is a usual practice to provide combined leakage and overload protection for transformer. So, this is a complete scheme in which the protection against earth fault and the protection against overloading is there. So, the earth relay, here we have two types of relay. Now, first is the earth relay has low current setting because the value of the earth leakage current is small as compared to the short circuit current. So, we are using a earth relay having a low current setting and operates under earth or leakage faults only. And the second relay is a overload relay. Now these relays have high current setting and are arranged to operate against fault between the phases. So this is a diagram for combined leakage and overload protection. So see here I have used two types of relay. The first is a earth relay, the second is a two overload relays. See, now these overload relay will respond for the face to face faults and this earth relay will respond for the